Hi friends, welcome to Alpha Mathematical Institute. In this video, we are going to discuss some problems related to permutation and combination. Okay, now let us discuss this problem first, right? So here the question is the summation r equals to 1 to 10 r square plus 1 into r factorial is equals to some options are given, right? Now let us solve this problem, right? So actually what is given, summation r equals to 1 to 10 r square plus 1 into r factorial. Okay, we need to find this summation. First, let us simplify this. So you just consider this quantity r plus 1 whole square. Okay, this r plus 1 whole square I can write r square plus 1 plus 2r. Okay, so r plus 1 whole square I can write like this. From this I can say this r square plus 1 is nothing but this r plus 1 whole square minus 2r. Okay, r plus 1 whole square minus 2r, like this we can write, right? Next, here r square plus 1 is multiplied with r factorial. Okay, so r square plus 1 is multiplied with r factorial. This can be rewritten as r plus 1 whole square minus 2r into this r factorial. So I can write this as r plus 1 whole square into r factorial minus 2r into r factorial. Okay, right? So in the next step I can do like this. So this r plus 1 whole square I can write 1 r plus 1 into another r plus 1. That r plus 1 into r factorial can be rewritten as r plus 1 factorial. Okay, minus, here you look at 2 times r into r factorial is there. So this 2 into r factorial can be written as r into r factorial minus r into r factorial. So now I need to compute this summation r equals to 1 to 10 r square plus 1 into r factorial. So this can be rewritten as summation r equals to 1 to 10 r plus 1 into r plus 1 factorial minus r into r factorial. This is one summation minus summation r equals to 1 to 10 r into r factorial. Okay, I am just splitting up this summation into two summations. Summation r equals to 1 to 10 r plus 1 into r plus 1 factorial minus r into r factorial minus summation r equals to 1 to 10 r into r factorial, right? Now let us take this quantity. Let us take this ur equals to r into r factorial. Okay, right? So this can be rewritten as summation r equals to 1 to 10. This is ur plus 1 because I have taken ur as r into r factorial. So r plus 1 into r plus 1 factorial can be written as ur plus 1 minus this is ur. Okay, this is ur. Now minus summation r equals to 1 to 10. Here you look at this r is there. This r I am writing as r plus 1 minus 1. Just I am adding 1 and subtracting into r factorial. Okay, so now let us simplify this. This is equals to summation r equals to 1 to 10. This is ur plus 1 minus ur. This is equals to this is not equals to, this is minus. Here I can write summation r equals to 1 to 10. This r plus 1 into r factorial, that can be written as r plus 1 factorial minus 1 into r factorial, that can be written as r factorial. Now let us take Vr is equals to r factorial. Let us take Vr is equals to r factorial. So what will happen? Summation r equals to 1 to 10. This is ur plus 1 minus ur, and then here minus summation r equals to 1 to 10. This quantity I am taking as r factorial, I am taking as Vr. So this is Vr plus 1 minus VR. This is VR plus 1 minus VR. Now let us simplify this. Now open up the summation. If I open up the summation, I will be getting, first I have to put u equals to 1 here. So this is u2 minus u1. Next I need to put u equals to 2 here. u3 minus u2. Okay. Next I need to put r is equals to, first I need to put r is equals to 1 here. So I will be getting u2 minus u1. Next r equals to 2. I will be getting u3 minus u2. Next I need to put r equals to 3. u4 minus u3 plus etc. Last I need to put r is equal to 10. Okay, before that I need to put r equals to 9. Let us put r equal to 9 here. What will happen? This is u9 plus 1, which means u10 will come. Okay, u10 minus u9. u10 minus u9. Next u11 minus u10. Okay, u10, right. Next plus if you open up this summation here, what will happen? I need to put r equals to 1 here first, right? So it will become v2 minus v1. Next plus v3 minus v2. Next plus v4 minus v3. Okay, plus etc. Last term r equals to 10. So it will become v11 minus v10. Okay, v11 minus v10. Now let us see. This is, some terms will get cancelled. This u2 and this u2 will be cancelling, and then this u3 and this u3 will be cancelling, and then here this u10 and then this u10 will get cancelled. So here what I get, minus u1 I'll get, and then plus u11 I'll get. Okay, and then here you just to look at here, this v2 cancel, and then this v3 and this v3 cancel. Okay, so etc. some terms will get cancelled. So this is last term. By putting r is equal to 10, I will get this last term. If I put the value r is equal to 9 before this term, I will get this one, v10 minus v9 I will get. Okay, so here these two terms will get cancelled. Okay, this term, this v10 and then this v10 get cancelled. So finally finally what I get, v11 I will get. Okay, so here minus is there, so this minus is common. So minus of here you just to look at, if we run the summation, this place actually I will be getting minus. Okay, outside minus is there, minus of here minus v1 will come here, plus v11 will come. Okay, plus v11 will come. So my final answer will be this one. So this is equals to u1. What is u1? So u1 means here we have set ur is equals to r into r factorial. So u1 means minus 1 into 1 factorial. Okay, plus u11 means 11 into 11 factorial. This is minus into minus plus. Okay, minus into minus plus. So this is v1. v1 means vr means r factorial. So v1 means 1 factorial. Okay, and then here minus v11. v11 means here 11 factorial. Okay, now here you just look at this 1 factorial and this 1 factorial will get cancelled. Here also 11 factorial, here also 11 factorial. You just pull out this 11 factorial outside. So here I will be getting 11, here I will be getting 1. So finally 10 into 11 factorial. Actually this is the correct answer, this question, 10 into 11 factorial. Let us see the options. Right, so 10 into 11 factorial. So option B is the correct answer. 10 into 11 factorial is the correct answer. Okay, now let us look into the next problem. See, this problem is also very important problem. In many times JEE mains ask this kind of problem. So let us discuss this problem. The value of 2 times 1 into P naught minus 3 times 2 into P1 plus 4 times 3 into P2 minus etc. up to 51 terms. Okay, this is one alternating series. 2 into 1 times P naught minus 3 into 2 times P1 plus 4 into 3 times P2 minus up to 51 terms plus 1 factorial minus 2 factorial plus 3 factorial minus 4 factorial etc. up to 51 terms, right? Now let us look into that. First let us consider this one. 2 into 1 P naught minus 3 into 2 P1 plus 4 into 3 P2 etc. Okay, this is alternating series. I am going to write this expression in summation notation. Summation R equals to, okay, summation R equals to, okay, I'll start the summation from R equals to 1 to 51, okay, because I need to sum up to 51 terms. Okay, summation R equals to 1 to 51. This summation is going alternatively, so I am writing minus 1 whole power R plus 1. Okay, here 2 is there, this is 1 P0. Okay, 2 is there, so R, if I put R equals to 1, I need to get to 2. So here I am writing R plus 2. This is R P, this is R minus 1. Right, now let us see whether this summation notation works or not. First, if I put R equals to 1, minus 1 whole power 2 will come. What is minus 1 whole power 2? Minus 1 whole power 2 is plus 1. Okay, here I will be getting 2. Okay, this term generates, right? And then this is 1 P0. First term got generated, and then next I need to put R equals to 2. So minus 1 whole power 3 will come. Okay, that is negative, right? So this negative generated, and then here 2 plus 1 3 will come, and then this is 2 P1 will come. Okay, remaining all other terms will get create. Okay, right, so I can write this summation in this summation notation like this. So this can be rewritten as summation R equals to 1 to 51. Let us simplify this one, minus 1 whole power R plus 1. Okay, and then this R plus 1. Next to look at this is R P R minus 1. You know the formula, NPR formula. NPR means n factorial divided by n minus r factorial. This is the formula for NPR. So this is RP R minus 1. RP R minus 1 means r factorial divided by r minus 1 factorial. Okay, r minus 1 factorial, right? So this can be rewritten as summation R equals to 1 to 51 minus 1 whole power R plus 1 into R plus 1 into R factorial divided by this R, this minus R will get cancelled. Here I will be getting 1 factorial. Now let us simplify this expression. This is equals to summation R equals to 1 to 51 minus 1 whole power R plus 1. R plus 1 into R factorial can be written as R plus 1 factorial. Now here I know 1 factorial. What is the value of 1 factorial? 1 factorial is nothing but 1 only. Okay, right. Now let us run this summation. If we run this summation, what I get, if I put R is equals to 1, minus 1 power 2 will come. That is plus 1. Okay, so this is 2 factorial. Next, if I put R is equal to 2, minus 1 power 3 will come. That is minus 1. Okay, minus. So here I will be getting 3 factorial. Okay, next I need to put R equals to 3. So here plus, this is 4 factorial. Next minus 5 factorial plus etc. Last I need to put R is equals to 51. Okay, if I put R equals to 51 here, minus 1 whole power 52 will come. That is plus. Okay, plus. Here 53 factorial will come, 53. So before this what I get, minus 52 factorial. Okay, minus 52 factorial. Last I am putting R is equals to 51. Then here what I get, 52 factorial only here I will be getting. Okay, because 51 plus 1, 52, right? Here if I substitute r equals to 51 minus 1 whole power 52 will come, that is plus 1, that's why plus. This is 52 factorial means this one is 51 factorial. Okay, this one is 51 factorial, right? So this is my this summation. Okay, so summation r equals to 1 to 51 minus 1 whole power r plus 1 into r plus 1 into rp r minus 1 equal to this summation, right? Now what they are looking for, they are looking for this sum. Okay, so 2 into 1 p naught, they are looking for this sum, 2 into 1 p naught minus 3 into 2 p 1, 3 into 2 p 1 plus 4 into 3 p 2 plus 4 into 3 p 2 minus etc. up to 51 terms. Okay, up to 51 terms plus. Okay, plus. Okay, plus. Next 1 factorial minus 2 factorial, 1 factorial minus 2 factorial plus 3 factorial minus 4 factorial plus etc. up to how many terms? Here also 51 terms. Okay, here also 51 terms. Now look at, I have calculated this sum. Okay, I have calculated this sum. What about this sum? This sum is nothing but from 2 factorial to 51 factorial alternatively, right? So that is 2 factorial minus 3 factorial plus 4 factorial minus 5 factorial plus 6 factorial minus etc. Last term, let us see the last term, 52 factorial. So minus here 51 factorial plus 52 factorial. And then here you look at 1 factorial, from starting onwards 1 factorial to how many terms? 51 terms. Okay, this is 1 factorial, 1 factorial minus 2 factorial, here sum. Okay, minus 2 factorial plus 3 factorial minus 4 factorial plus 5 factorial minus 6 factorial plus etc. Last term. Okay, last term 51 factorial. 51 factorial will be coming as plus or negative, that we need to decide. See, odd terms will get positive only. So here I will be getting plus 51 factorial. So what is our final answer? So this is equals to, now look at this plus 2 factorial minus 2 factorial cancel, minus 3 factorial plus 3 factorial cancel, plus 4 factorial minus 4 factorial cancel. In the similar way, minus 51 factorial plus 51 factorial get cancelled. So finally I will be getting 52 factorial here, and then here plus 1 factorial. So we know 1 factorial is nothing but 1. So this is 52 factorial plus 1. Okay, so the answer is 52 factorial plus 1. Let us see whether 1 plus 52 factorial. Okay, so correct answer to this question is 52 factorial plus 1. Okay, right. Now let us discuss some more problems. Right. So this is one of the very good problem. So if 1 divided by n plus 1 NCN plus 1 by n NCN minus 1 plus etc. 1 by 2 into NC1 plus NC0 equals to 1023 divided by 10, then n is equals to. Okay, so actually what is given, so given information I am writing from here. Okay, so this is first NC0 plus 1 by 2 into NC1 plus 1 by 3 into NC2 plus etc. plus this term I am writing 1 divided by n into NC n minus 1 plus 1 divided by n plus 1 into NCN. Okay, NC 1 divided by n plus 1 into NCN. This is equals to 1023 divided by 10. Okay, right? I am writing this in the summation rotation. See, look at this is NC0. This is 1 by 2 into NC1, 1 by 3 into NC2. Next 1 by 4 into NC3 will come, etc. 1 by n plus 1 into NCN. Okay. 1 by n plus 1 into here, what is that? NCN. Okay, NCN. See, I need to write this in the summation notation. So first this term I can write 1 by 1 into NC0. This is 1 by 2 into NC1, etc. This is next term 1 by 2 into NC2, etc. 1 by n into NCN minus 1. This is 1 by n into NCN equals to 1023 divided by 10. Okay, 1023 divided by 10. Actually here 1 divided by n plus 1 into NCN. Okay, NCN, right? Now let us rewrite this in the summation notation. I can rewrite this as summation R equals to here you look at R equals to summation R equals to this denominator is varies. Here 1, here 2, here 3, here n plus 1. Okay, so I am writing 1 divided by R plus 1. R equals to 0 to n. Okay, R equals to 0 to n. 1 divided by R plus 1 NCR. Okay, this is equals to 1023 divided by 10. Now you look at summation R equals to 0 to n, 1 divided by R plus 1 into NCR. If I put R is equals to 1, what I get? 1 divided by 1 NC0. If I put R is equal to if I put R equals to 0, I'll get 1 divided by 1 NC0. If I put R is equals to 1, I'll get 1 divided by 2 into NC1. If I put R is equals to 2, I'll get 1 by 3 into NC2 plus etc. Last, if I put R is equals to n, what I get? 1 divided by n plus 1 into NCN. So this is perfectly correct. Okay, summation notation we have written. Right, now how to find this sum? Summation R equals to 0 to n, 1 divided by R plus 1 NCR. I need to compute this. Okay, already we have studied this in permutation and combination. Okay, let us see how to compute. Already we have studied this in binomial theorem. Okay, so I'll do it here. So we know summation R equals to 0 to n NCR x to the power r is nothing but 1 plus x whole power n. Okay, summation R equals to 0 to n NCR x to the power r is nothing but 1 plus x whole power n. Now integrate on both sides. So if I integrate on both sides, here summation R is equals to 0 to n, this NCR integral x power r into dx is equals to integral 1 plus x whole power n into dx. Okay, this is indefinite integral, so I need to add some constant c here. So I am adding that constant c. Right, now this will become summation R equals to 0 to n, this is NCR x power r. If I integrate, I will be getting x power r plus 1 divided by r plus 1. This is equals to 1 plus x whole power n. If I integrate, I will be getting 1 plus x whole power n plus 1 divided by n plus 1 plus c. Okay, I need to determine what is this constant c. Okay, for that what I am doing, let us take this as equation number 1. Put x is equals to 0 here. Put x equals to 0 here. So what I get, if I put x is equals to 0, this entire term will become 0 because this term is 0. This summation, if I put x equal to 0, 0 to the power r plus 1, we will get 0 only. So this is summation, this entire term is 0, right? This left hand side is 0. Okay, this left hand side 0. So 0 equals to, here you look at 1 plus 0 whole power n plus 1. That means 1 power n plus 1. 1 to the power anything, you will get 1 only. Right. So 1 divided by n plus 1 plus c. So from this I can say this c value is equals to minus 1 divided by n plus 1. So c value I have found minus 1 divided by n plus 1. Okay. Right. Now in the first equation, put x is equals to 1. In the first equation, put x equals to 1. So what will happen? Summation r equals to 0 to n. This is NCR. This is 1 to the power r plus 1. What is 1 to the power r plus 1? Simply 1. Okay. So this is 1 divided by r plus 1 equals to here 2 power n plus 1 divided by n plus 1. Okay, because 1 plus 1 is 2. So 2 power n plus 1 divided by n plus 1. And I know the c value is minus 1 divided by n plus 1. Okay, now let us simplify this. This is equals to here LCM is n plus 1 is the LCM. So here 2 power n plus 1 minus 1. So summation r equals to 0 to n NCR 1 divided by r plus 1 is this quantity, but they have given this sum as how much? 1023 divided by 10. Okay, 1023 divided by 10. They have given this sum as 1023 divided by 10. This is equals to 2 power n plus 1 minus 1 divided by n plus 1. Okay, if you compare both, okay, so I can say this n plus 1 could be 10. So from this I can say n is equals to 9. So value of n is 9. See, once again we need to check it also. Here if I put n is equals to 9, this is 2 power 10 minus 1. If I put n is equals to 9 here, this is 2 power 10 minus 1. 2 power 10 is nothing but 1024 minus 1. This is simply you will be getting 1023. That is sitting here. Okay. So I can say the value of n is 9. Value of n is 9. So the correct perfect answer to this question is 9. So this is the correct answer. Okay. 9 is the correct answer. Right? Right. Okay. Let us discuss one more problem. Right. So actually this is very nice problem. So let us discuss this problem. Let Tn be the number of all possible triangle formed by joining the vertices of an n-sided regular polygon. Okay. If Tn plus 1 minus Tn is equals to 10, then the value of n is dash. Some options are given. Tn be the number of all possible triangles joining vertices of an n-sided regular polygon. If Tn plus 1 minus Tn is equals to 10, then the value of n is dash. See, actually here you are having n-sided regular polygon. Okay, here you are having n-sided regular polygon. See, suppose you just consider this equilateral triangle. Okay, you consider this equilateral triangle. Okay, all the sides are equal here. This is three-sided regular polygon. Okay, and then you consider the square. Okay, this square. Here all the sides are equal. Okay, right. This is four-sided regular polygon. So in the four-sided regular polygon, 4 vertex are there. In the three-sided regular polygon, 3 vertex are there. So in general, on a n-sided regular polygon, n vertices will be there. This is your first point. Okay, on n-sided regular polygon, n vertices will be there. Okay, right. Now just to look at here what they have given. Tn be the number of all possible triangles formed by joining the vertices of an n-sided regular polygon. Okay, so n-sided regular polygon has n sides. One triangle can be created by taking 3 distinct points. Okay, so a triangle, okay, a triangle is Okay, a triangle is uniquely, okay, a triangle is uniquely determined by three three non-collinear points, non-collinear points. Okay, three non-collinear points. A triangle is determined by three non-collinear points, right? So here n-sided polygon, right? So n points will be there. So if we choose any three points out of these n points, we can create a triangle. Okay, if we choose any 3 points out of these n points, we can create the triangles, right? So Tn is equivalent to saying choosing, okay, choosing three vertices, out of n vertices. Okay, out of n vertices. Okay, out of n vertices. This is the first point you know, you need to understand. If you choose three non-collinear vertices, then you can create a triangle. Okay, so no problem. So Tn means choosing three vertices out of n vertices. Okay, this event and then forming triangle event are same only. Okay, right? So here what is given? Here one equation is given, right? Tn plus 1 minus Tn equals to 10. This is given. Okay, what is Tn plus 1 according to the question? Tn plus 1 means the number of ways of choosing three vertices out of n plus 1 vertices. That's very important. Okay, Tn plus 1 means the number of ways of choosing three vertices out of n plus 1 vertices. So this is n plus 1 C3 minus this is nC3, which is equals to 10. Now what is n plus 1 C3? N plus 1 C3 means n plus 1 into n minus 1 divided by 3 factorial minus nC3 means n into n minus 1 into n minus 2 divided by 3 factorial equals to 10. Now look at here also 3 factorial, here also 3 factorial. You just take 3 factorial out, and then here n, here also n. So take this n into n minus 1 also out. So what will be remaining here? Here remaining is this n plus 1 minus here this remaining is this n minus 2. So this is minus n plus 2. Okay, this is equals to 10. Okay, this is equals to 10. Now let us simplify this. 1 divided by 3 factorial is nothing but 6, we know, right? So this is n into n minus 1. This n will get cancelled. Here 2 plus 1 we will be getting 3, which is equals to 10, right? Now let us simplify this. This will get cancelled. Here I will be getting 2. Okay, so n into n minus 1 equals to 20. N into n minus 1 equals to 20. So n square minus n minus 20 equals to 0. This is a quadratic equation. N square minus n minus 20 equals to 0. Now I can write n square minus 5n plus 4n plus 20 equals to 0. If I multiply minus 5 by 4, I will be getting minus 20. Okay, I will be getting minus 20. So I am doing the middle term factorization. Here also n is there, here also n is there. So just to take n outside, n into n minus 5 plus you take 4 outside. This is also n minus 5, which equals to 0. Now n minus 5, n minus 5. Take this n minus 5 outside. Here you take n plus 4. So from this I can say either n equals to 5 or n is equals to minus 4. Here n represents number of vertices of a n-sided polygon. Okay, so this n there is no possibility of n being negative number. Okay, so n must be positive only. So we need to take n is equals to 5 only. So the correct answer to this question is n equals to 5. Okay, the correct answer to this question is n is equals to 5. See, actually this is very what to say, interesting problem, right? So when n is equals to 5, this will hold, right? Now let us see the problem. Look at this problem. This also one of the wanted problem in JEE mains. The problem says that the sides AB, BC and CA of a triangle ABC have 3, 4, and 5 interior points respectively on them. The number of triangles that can be constructed using these interior points as a vertices is, actually there is a triangle ABC. Okay, so let us construct a triangle now. So you just consider there is a triangle ABC, right? So this is my triangle, right? So this is my vertex A, this is my vertex B, this is my vertex C, right? So the side AB, BC and CA of a triangle have 3, 4, 5 interior points respectively. So in the side AB, 3 interior points are there. Okay, I call that first interior point as A1. Okay, and I call the second interior point as A2, and then this point as A3. Okay, A3, right? In the side BC, how many interior points are there? 4 interior points. Okay, let us say this interior point is B1, and then this interior point is B2, and then this interior point is B3, this interior point is B4. Okay, and in this side AC, 5 interior points are there. Okay, so I'll take this as A1, and then this is A2, and then this is A3, and this point is A4, this point is A5. Okay, 5 interior points are there, right? Here the question is asked for the number of triangles that can be constructed using these interior points as vertices. Okay, by using these interior points, how many vertices you can construct? See, look at along the side AB, I can choose any one of the vertex. Okay, like this A1. Okay, and along the side BC, I can choose any one of the vertex like B2. Okay, along the side AC, I can choose any one of the vertex like this A3 or A2. Okay, so I can create one triangle like this, right? So let us create the triangle. So this triangle, this triangle. Okay, I can create one triangle. Okay, each side I am selecting one vertices and I am creating this triangle, right? In how many ways I can create a triangle like this? See, this side 3 interior points are there, so number of ways of selecting one single point from this 3 points is in 3C1 ways. Okay, is in 3C1 ways. Here in number of from the number of ways of selecting one point out of these 4 points is nothing but 4C1. Number of ways of selecting one point out of these 5 points is nothing but 5C1. Okay, this is actually what is this? This is by taking one vertex along the side AB and one vertex along the side BC and one vertex along the side AC, I can create these many triangles, right? But there is some other possibilities also to create the triangles. Okay, so let us explore that possibilities also. See, in the side AB, I can select some other two. I can select any 2 vertices. Okay, so I am selecting these 2 vertices, A2 and A3. Okay, after selecting these two vertices, I can select any one vertex from BC. Okay, so I'll select this vertex. Okay, and I can create a triangle like this. Okay, and after selecting these two vertices, I can select any vertex from these five vertices. Take this one, and I can create a triangle like this. Okay, I can create a triangle like this, right? So I can create a triangle like this. So number of ways of choosing any two vertices along AB is nothing but 3C2. Along AB is nothing but 3C2. Selecting two vertices along AB is nothing but 3C2. That is 3C2 into number of ways of choosing one vertex along BC is 5. Okay, this is one possibility. And the number of ways of choosing two vertices, number of ways of choosing two vertices along AB is 3C2, and selecting one vertex along this AC is 5. Okay, this AC is 5. Actually here BC I told, right? So here BC, number of ways of selecting one vertex along BC is 4C1. That is nothing but 4, right? Here 5. And then plus similar things we can do it along the side BC. In the side BC, I can select two vertex, right? So the two vertex, in how many ways I can select two vertex out of 4 vertex? In 4C2 ways. So here 4C2, and then here I need to select one vertex. That can be done in 3C1 ways, plus next 4C2. Here I can select one vertex. That can be done in 5C1 ways, and then from this side I can select two vertices, 5C2 into this is 3C1, and then 5C2 into this is 4C1. Okay, 4C1. Right, now let us simplify this. So this can be rewritten as 3C1 is 3, 4C1 is 4, 5C1 is 5. Okay, and then 3C2 is equal to 3C1. So it is also 3 into this is 4C1 is nothing but 4 plus 3C2 is 3 into 2 divided by 1 into 2. Once again 3C1 itself you can write. So 3C1 into 5 plus 4C2, 4 into 3 divided by 1 into 2, 3C1 3, right? Next 4C2, 4 into 3 divided by 1 into 2 into 5C1, that's 5, 5C2, 5 into 4 divided by 1 into 2 into 3C1 3, 5C2, 5 into 4 divided by 1 into 2, this is 4. Let us simplify this. So this is equals to 3 into 4, 20. 3 into 4, 12. 12 into 5, 60. Okay, this is 60. 3 into 4, this is 12. Okay, so this 2 will get cancelled. 3 into 5 will be getting 15, right? Plus this 2, and then this 4 will get cancelled 2. So 2 into 3, 6. 6 into 3, 18. Okay, plus this 2, and then this 4 will get cancelled. 6 into 5, 30. Okay, 6 into 5, 30. So this will get cancelled. 10, this is also 30. Okay, this 2 and then this will get cancelled. 10, this is 40. Okay, so let us simplify this. 40, 30, this is 40, 30, 70, this is 100. Okay, this is 100. So 100 plus 60, 160. Okay, 30, 160, and then here 12 plus 15 plus 18 is there. So we'll be getting 8 plus 5, 13, 13 plus 2, 15, remaining 1. Okay, 1. So 2, 3, this is 4, 4 plus 6, 10. Okay, 4 plus 6, 10, remaining 1, 205. Okay, so the number of such triangles can be constructed using these points as interior is 205. Okay, so the correct answer to this question is 205. Okay friends, if you like this video, please subscribe to Alpha Mathematical Institute, and if you like this video, please share with your friends also. Thank you for watching Alpha Mathematical Institute.